Hey guys, happy Friday. I apologize off the bat for my crazy voice. Just imagine I'm like an old lady who smoked a pack a day for 50 years, and that's about what I imagine I sound like. Anywho, we're going to talk about our next shape today, which is a kite. So before we do that, I want to review the shapes that we've already discussed. Okay, we've talked about quadrilaterals, which just have four sides. So quadrilateral just has four sides. Then we talked specifically about a parallelogram. 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 And a parallelogram was a shape with four sides, but specifically it had two pairs of parallel sides that were opposite and congruent to each other. So these were parallel and these were parallel. And they were also all congruent, or the opposites congruent. And then we talked specifically about a rectangle. And that rectangle was a special type of parallelogram, meaning its opposite sides were also congruent and parallel, except additionally, one of the main differences, was that it has four 90-degree angles. And it also has some other qualities about its diagonals on the inside, but that was the main difference that we can easily relate to. And then we learned about a rhombus, or rhombi for plural. And a rhombus kind of looks like a square that just got knocked over a little bit. So remember, a rhombus is also a parallelogram, right? Its opposite sides are parallel. It's not a rectangle because its four right angles are not congruent to each other. They're not 90-degree angles. Okay, but additionally, its four sides are all the same. So a parallelogram can have two sides that are different sizes, but a rhombus will have all four of those sides the same. And then we also talked about a square. And a square is a parallelogram because its opposite sides are parallel and congruent. And it's also a rectangle. A square is a rectangle. I know that kind of sounds weird, but it is. All it takes to be a rectangle is the same properties as a parallelogram plus those 90-degree angles, which a square also has. And it also is a rhombus because all four of its sides are congruent as well. And more specifically, it has all the properties of a rhombus and a rectangle put together. And that's why we got a square. And then yesterday, we talked about a trapezoid. And the main difference between all these shapes here and a trapezoid was that the trapezoid only had one pair of parallel sides. I don't even know what that mark is. Sorry. One pair of parallel sides. That's it. The other pair could be congruent, but not necessarily. But they're definitely not parallel. So a kite is also kind of an oddball. It is still a quadrilateral, but it has exactly two pairs of consecutive sides. So remember, the word consecutive means like one after another. So in other words, no opposite sides are congruent. And it's not a parallelogram because no sides, or a trapezoid because none of its sides are parallel. Okay, so here is an example of a kite. Now, a kite's not just like a toy, it legit is a geometric figure. So let's talk about some very important aspects of a kite. There are four. First one, diagonals are perpendicular. Perpendicular, meaning they intersect at 90-degree angles. So perpendicular. So if they intersect at 90-degree angles, I can go ahead and mark all four of those angles are at 90 degrees. The second quality of a kite is that exactly one pair of opposite angles are congruent. So only one of its pairs, so either A and C are congruent to each other, or B and D are congruent to each other. And what I want you to notice is if I look at angle B, do you notice how that's an acute angle? And then if I look at angle D, do you see how this is actually bigger than 90 degrees? Therefore, those angles are not the same. So in this particular kite, we're going to say that angle A is congruent to angle C. Now, how do you know what that's going to be on any other given kite other than just by looking at it? So the trick to kites is that if we fold kite, and I want you to write this, fold kite along big diagonal. If you fold the kite along the big diagonal, it will make two congruent triangles. Fold the kite along the big diagonal to make, I forgot the word make, to make two congruent triangles. So the big diagonal is literally just which diagonal in the middle is bigger. So in this case, obviously DB is longer. So that's important. If you don't have a highlighter or color or something, I want you to like shade over DB and make it pretty dark. This big diagonal is also called the line of symmetry. The line of symmetry. So that means every part of the triangle on top is the same as every part of the triangle on the bottom, right? Angle A is already congruent to angle C. So let's talk about some of the other things. By definition, we said a kite has two congruent consecutive sides. So that means AD must be congruent to DC if we fold it over, right? And that side AB must be congruent to side BC. And then in the middle, well, let me fill out actually this next quality, I'll say, this next feature of a kite. It says the longer diagonal bisects the shorter diagonal. So y'all all know that the word bisect means cut in half. So the longer diagonal is DB. It means it cuts the diagonal AC in half, which means this short segment from A to that middle, oh, I don't know where my 90-degree angles went, and from that middle to C is going to be congruent to each other. And that makes sense because we said that if you fold it over that line of symmetry, you would get congruent triangles. Okay, lastly, the longer diagonal bisects a pair of opposite angles. So again, the long diagonal is the one we highlighted, DB. If it bisects the angles, that means it cuts those angles in half. So that means angle B was cut in half. So that means this small angle must be congruent to the small angle below it. And at angle D, that angle, I'm going to use 3 arc marks, is congruent to its angle below it. So the key feature is don't try to memorize these qualities about a kite. This is the deal. If you fold the kite along the big diagonal, you will make two congruent triangles. So figure out which diagonal is your biggest, shade that diagonal real dark, and then know that everything on one side will match the other side. Okay, so let's use those features and let's actually do some problems. So number 1 says, in kite ABCD, it says the measure of angle DAB is 54 degrees. So let me figure out where is that. D to A to B is 54 degrees. So I'm going to, let me just erase my not straight lines. DAB is this angle, this big angle, and that is 54 degrees. So both of those small angles together are 54 degrees. It also says the measure of angle CDF is 52. So again, if you connect the dots, C to D, D to F. So this red angle must be 52. So this one is 52. The question is, find the measure of, and then it wants us to find 3 different angles. So we're going to do one at a time. The first one is going to be, find the measure of angle BDC. So let's trace that out. BDC. B to D, and then D to C. Well, what do you notice about that angle? It's already labeled. So you just found your first answer without even doing anything. It's just another name for that angle. So the measure of angle BDC is 52 degrees. Okay, so there's one. The next one, and let me erase this mark here. The next question is, what is the measure of angle ABC? So if I trace that out, here's A to B, here's B to C. So angle ABC is this green angle here. So this is where you have to do some work. In order for me to find this, as I mentioned earlier, I want to trace over my big diagonal. So the long diagonal in this case is this one. And that means every angle that's on the top is the same as on the bottom. Okay. The other thing to remember about a kite is that these four angles in the middle are all 90 degrees. So you have literally a couple different ways that you could solve this problem. And I'm only going to show you one. So if you want to solve it a different way, know that there are a few others. But here's one option. I know that if I find, you're going to have to pay attention to what I'm about to mark. I know that if I find this small green, highlighted green angle here, and this small highlighted pink angle, I can add those two angles together and get angle ABC. So let me do that. Well, if I take 54 degrees and I divide it by 2, then I get 27. So what that just helped me find is that this angle over here to the left, the big angle is 54, but divided by 2 means that these two small angles will be 27 and 27. And if that small angle is 27, then I can look at this blue triangle. I know that the three angles of every triangle add up to 180 degrees. So I already know that one of those angles is 27. I know the other angle is 90. So if I want to figure out the third angle just in that blue triangle, then I can add 90 plus 27, get 117, and then 180 minus 117 is equal to 63. Now that's not my answer. That gives me this green highlighted angle, 63. So I need the other part of angle B in order for me to find the answer. So I need that pink highlight. Well, I can use a similar tactic, or I can remember that this 52 degree angle here on the bottom, if I folded over the yellow highlight, then it should match exactly. So this 52 degrees is going to be the same as this highlighted pink angle because it's reflected over that yellow highlight. So that other angle is 52 degrees. So then if I add these two angles together, I'll get the total for ABC. So then I'm going to do 63 plus 52, and I'm going to get the measure of angle ABC is 115 degrees. So there's my second answer for the measure of angle ABC. Okay, the last one is, what is the measure of angle FDA? FDA. So again, let me trace that out. I'm going to trace it in this gray color. So here's F to D, and here's D to A. So I'm looking for this gray angle right there. Well, again, if you use your reflection property, you found over here that this green angle was 63 degrees. And if we reflect it over, if you fold that kite over the yellow highlight, it's going to match up to this gray angle. So there's your third answer. The measure of angle FDA is also 63 degrees. So there's nothing to even solve for there. All right, number 2. It says in kite PQRS, find the measure of angle PQR is 78 degrees. So let me label that. P to Q to R. So this big angle PQR is 78 degrees. Then it says the measure of angle TR. Oh, y'all, I'm so sorry. TRS is 59. So if you trace that out, T to R to S is here. So that's 59 degrees. Question is, Find the measure of angle QRT and the measure of angle PSR. So let's first locate where is angle QRT. So Q to R to T is going to be this pink highlighted angle there, right? QRT. So you could do a few different things, but my recommendation is to remember that the four angles in the middle of your kite are 90 degrees. So then if I focus in just on this top triangle here, we know one of its angles is 90 degrees, and we know part of the other angle is 78, but we also know this. If this is my long diagonal, then everything on each side of those diagonals is congruent. So that 78-degree angle was split in half. So then if I take 78 degrees and I divide it by 2, then I end up with 39, which means the top part of this angle is 39 and the bottom part is 39. Well, again, if I just look at that blue triangle, I know one angle is 90. I know the other angle is 39. So if I add 90 plus 39, I get 129, which means if I want to find that pink highlighted angle, I'm going to subtract 180 minus 129, and I'm going to get 51. So there's my first answer. The measure of angle QRT is 51 degrees. Okay, next, the measure of angle PSR. So let me figure out where that angle is. PSR is going to be this big blue highlighted angle, P to S to R. Again, there are lots of different ways that you can solve for this. I recommend you focusing on the small triangles. So let me focus in on, actually, you know what? Look at it this way. Let's focus on this green highlighted triangle. So look at what we got here. You know that this top angle is 59 degrees. And you also know that if you fold the kite over the yellow highlighted mark, that this angle down here at the bottom should also be 59 degrees. If you focus in on that green highlighted triangle, you know two angles of that triangle are 59 and 59, and you're looking for the third angle, which is blue. So then if I add 59 plus 59, I get 118. And then if I subtract 180 minus 118, I get 62. So there's my last answer. The measure of angle PSR equals 62 degrees. I want to reiterate that there are lots of different ways that you could actually solve for those angles using the various triangles that are in your shape. So please know that the ways that I did it here are not the only ways that you could do it. If you find other ways, as long as you're following like geometry rules, I'm okay with that. Okay, our last example, it says find the indicated segment. Find the indicated segment of the kite. I don't even know what that means, but I do know that I'm just going to solve for these three lengths here. Now, notice this is different. The first question is, what is Rx? Rx. So what I want to do is label that segment with a variable. So Rx, so as not to confuse, we usually use X as a variable. But we already have X as a point. So I'm just going to call that right there segment A. R to X is segment A. Question is, what is the length of that? Well, notice I'm not dealing with angles in my kite anymore. I'm dealing with the segment lengths. So what you need to remember about a kite is that if the four angles in the middle are 90-degree angles, that means the four triangles on the inside are right triangles. And if they are right triangles, if we focus in on this green triangle, how could I find the third length of that triangle? If I know two of them, I know 12, and I know the hypotenuse is 13. Is there a way that I could figure out the third side to that triangle? And I'm hoping maybe somebody came up with the Pythagorean theorem when I just asked that. A squared plus B squared equals C squared. So if I plug in my numbers in that green triangle, then I get A squared plus 12 squared equals 13 squared. And then if I solve this, so then I get a squared plus 12 squared is 144 equals 13 squared is 169. If I subtract 144 from both sides, then I get that a squared is equal to 25. And then if I want to get a by itself, I'm going to take the square root of both sides, which means that a will equal 5. So remember, a stands for Rx. So there's your first answer. Okay, the next one, it says find xt. xt. Let me pick a different color. xt, let's call this length, I mean, you could pick any, you call it b if you want. So this time we're going to be focused in on one of the right triangles that has b on it. So maybe I'll focus in on this top right triangle. So I know the bottom is b. I know it's a right triangle, 90 degrees. I know the left side is 12. I also know that the top, the hypotenuse, is the same as this one because they both have 2 tick marks. So I also know that that's 15. So I can solve for b by doing the Pythagorean theorem again. I can do 12 squared plus b squared equals 15 squared. So that's going to be 144 plus b squared equals 225. And then if I subtract 144 from both sides, then I get b squared is equal to 81. And then to get b by itself, if I take its square root, I get b equals 9. And remember, b is representing the segment xt, which is 9. Okay, the last question is, what is rt? Well, rt is from r all the way to t. Well, we could just add together the 2 lengths we just got for a and b. So we could just do 9 plus 5 and get 14. Okay, so that's how you solve that one there. For the sheet that goes along with this, the worksheet on the backhand side, you need to, the first section is just true, false. Okay, so 1 through 6, you're going to use what you know about kites on the other side, and you're going to use this picture here. And so the first one says, like, the measure of angle GKJ equals 90 degrees. So figure out where is GKJ on the picture, and if this is a kite, is it true that that angle should be 90 degrees? So you'll go and do the true, false. For 7 through 10, I'm giving you side lengths. Okay, so if I'm giving you side lengths, your hint for 7 through 10, not for all of them, but for some of them, is going to be Pythagorean theorem. So if you want to write that as your hint for this group, Pythagorean theorem. That's what you're going to use for some of 7 through 10. Notice number 9 says simplest radical form, and number 10 says round it. So here's what simplest radical form means. The square root of 3 is in simplest radical form. It can't be simplified anymore, right? So the square root of 3 is as simple as we can go. But if I give you something like the square root of 12, that one is not in simplest radical form. The reason being is because even though 12 isn't a square number, so we can't take the square root of 12, there is a square number that goes evenly into 12. So remember, your square numbers, in case you forget, your square numbers are like 1 squared is 1, so 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 36, etc. So these are square numbers. If these numbers are under a radical symbol, or under a square root, you should be able to take them out. So if you look at this list, 4, 9, 16, 25, which one of those numbers divides evenly into 12? Well, hopefully you said 4. And 4 goes into 12 3 times. So instead of the square root of 12, I can rewrite that to be the square root of 4 times the square root of 3. And what is the square root of 4? Well, the square root of 4 is 2. So this would be the simplest radical form for the square root of 12, writing it as 2 square roots of 3 instead. So know that you're going to have to do that for number 9. When you get your answer, you'll have to break it down like that. Number 10 is different. Number 10, you're just going to round it to the nearest hundredth. Okay. 11 and 12 are dealing with angles. Okay, so that's not going to be Pythagorean theorem. This is just going to be using what you know about the kite to find your angles. Also remember about this kite. If you want, every time I see a kite, I always figure out what my long diagonal is first. And I just highlight that or darken that so that I know that I can fold it over that diagonal and everything will be congruent on the other side. 13 through 17, all of this is dealing with angles, okay? WY is the long diagonal, so the, no it's not, just kidding. Here's how I know that. If it's kind of hard to see, is WY longer or the same distance as XZ? If you have a hard time seeing that, look at what's already marked on the picture. Do you see how WX has one tick mark and it's the same as XY? And WZ has two tick marks and it's the same as ZY? That's telling us that this kite can be folded over XZ and everything would be the same. Okay, so that one's going to be your long diagonal there. Okay, 13 through 16 are all dealing with angles, so you won't use the Pythagorean theorem at all here. You're going to use what you know about the angles of a kite to answer this. Okay, so your task is to get through these questions before the end of class. This is not to be taken for homework. This is to be done here and now in class and to check your answers or check our answers as a class even before we leave. And you get to walk out of here homework free for your weekend.